Okay, there was a similar post for this kind of problem that's already been answered, but let's do it for this one where one of the pieces or one of the rules is actually a downward opening parabola. So if you rewrite this as negative x squared plus 36, you can think of this as the parabola negative x squared shifted upward 36 units. So that's what this graph looks like. But we're only using the parabola from negative 6 to 0. And so if you make up a little table to plot those points, this point right here, 0, 36, is going to have an open circle because 0 is really not in the domain for this rule. It's in the domain for this rule. And the endpoints that were used for this rule are 0 and 6. So if I plot those 2 points, I do get a linear graph with a slope of 2 and a y-intercept of negative 1. Now, looking at this graph, you can tell that there is an absolute minimum at negative 1. The absolute at 0. The absolute min is negative 1. You can't get any lower than that, but that negative 1 is an exact value. On the other hand, there is no absolute max because an absolute max must be an exact real number. It's bounded above by 36, but we can't actually ever get there. If I say, for example, what's f of negative 0.0001, I get 35 point, look at all those 9s. And the more zeros I put in here, the more 9s I'll get over here, but I will never actually get to 36. So no absolute max, absolute min at 0 has a value of negative 1. There you go. Hope that helped. If you have any questions, post a comment. Oh, by the way, this is how you write a piecewise function on Desmos. You use the braces. You first have the rule, the domain or the piece of the x-axis that you're going to use, colon the rule, comma, the next piece of the domain, colon the rule. Okay. And I'll post a link to the Desmos graph that generated this. There you go.